Hello there. Here I have a lesson on solving rational equations, and as we go through this, we're going to learn how to actually solve a rational equation, but then we're also going to be able to identify extraneous solutions to those rational equations, because sometimes they have them. So I'm just going to start off with solving rational equations. This first one, I think a lot of times what I would do if it was this one, I wouldn't solve it using the techniques that I'm going to use in the rest of it. Most of the time when I would solve an equation like this, I would look to cross multiply first. I'd multiply those two parts together, multiply these two parts together, set them equal, and go from there. Because that would probably, in my mind, be the easiest way to go about this. But I'm going to show you a different method that's going to help us solve the equation here on the right. So I'm going to get rid of this. I'm going to look at solving this equation. Now, I don't really like to have fractions any more than the next person. So I look at this and go, how could I get rid of the fractions? Well, if I wanted to get rid of the p plus 3 on the left side, I would need to multiply by p plus 3. And by doing that, that would allow the p plus 3's to divide out on the left side. But if I multiply the left side by p plus 3, I'm going to have to multiply the right side, by p plus 3 as well. So I'm going to put a p plus 3 on the right side. But that just would eliminate the denominator on the left side. I also wanted to eliminate the denominator on the right side. So to do that, I'm going to have to multiply by p minus 6. Because if I multiply by p minus 6 on this right side, then the p minus 6's on the right side are gone. And then I have no fractions remaining in my equation. So that's what I'm going to do. Now, what I want you to recognize is the p plus 3, p minus 6 would be the common denominator to the two fractions. So really what I'm doing is I'm identifying the common denominator, and then I'm going to multiply both sides by it, because then I won't have to worry about fractions anymore. So let's go ahead and let's do this multiplication. So when I multiply on the left side, remember the p plus 3's are going to divide out. So now all I have to do is multiply the 8 times the p minus 6, and I'm going to end up with 8p minus 48 equal to, and now on the right side, remember, the p minus 6's are going to divide out, and now all I have to multiply is the 2 and the p plus 3, and now I'm left with 2p plus 6. Now I have a little equation that I'm pretty confident that everybody can solve this. So the first thing I would do is I'm going to add 48 to both sides. And I'm going to put two things together at once. I'm going to move all of my constants to the right side, which I've done by adding 48 to both sides. And I'll move all my p's to the left side by subtracting p from both sides. Because now I have 6p equal to 54. And then my final step here is going to be to divide by 6. And when I divide by 6, I find out that p equals 9. Now, with a rational equation, we need to check to make sure that this solution of 9 does not make the denominator in the original equation equal to 0. Because if the original equation has a denominator of 0, we can't divide by 0, and that wouldn't make sense. But if I go to my first denominator, well, 9 plus 3, that's 12, that's okay. And if I go to my second one, 9 minus 6, that's 3, and that's okay as well. So then, yes, p equal to 9 is the solution to that first rational equation. Now my second one, I'm going to go back and look at that approach that I used in the first one. I said if I find the common denominator and multiply everything by it, both sides, then I will eliminate all fractions. So to do that, I'm going to have to factor this denominator here. So the factors of v squared plus v, that would be v and v plus 1. So now I can kind of ignore that. I've just put it in factored form. And now my common denominator, now amongst all three fractions, well, I notice that v is going to be part of that common denominator, and v plus 1. So there is my common denominator. It's v and v plus 1. So I'm going to multiply this entire left side by that, and then I'm going to multiply the right side by v and v plus 1. All right, so really what I have to do now is I have to take this and distribute it to here, and I have to distribute it to here. So when I take the v times v plus 1 times 5 over v plus 1, the v plus 1s will divide out, and they will be gone. And then all I'm left with is the 5v. But I can't really cross these off because I don't want to confuse that v plus 1 is gone. So I'm just going to get rid of that. I just want you to think that those are gone. So we're left with, like I said, just the 5v. And now we're going to have plus. Now we have to multiply the red. So when I do that, now remember the v's are going to divide out. But again, I don't want to mark that because I don't want to confuse with the first fraction multiplication. So I'm going to just leave it there, but realize that the v's are going to divide out. And now all we're going to be left with is v plus 1 times 1, which is v plus 1. And then that's going to equal, now the right side of this equation, so it's just the one fraction on this side, I can actually divide this v and v, those will divide out. The v plus 1 and the v plus 1 will divide out. So then the right side just equals 2. And now I continue solving my equation. So what I'm going to do is I'm noticing that I need to get rid of this 1 on this side. So I subtract 1 from both sides, and now I have 6v equal to 1. If I now divide both sides by 6, I get v equal to 1/6. And now remember I said we have to make sure that that solution does not make any of our denominators equal to 0. So if I put 1/6 in to this first one, 1/6 plus 1 is not 0, so that's good. Well, we'd have v is 1/6, that's not 0. And if I put it here, I would end up with 1/6 times, what, 1 and 1/6? That's not going to multiply to be 0. Therefore, yes, this is the solution to that rational equation. Let's try another one. Now notice on this one, finding our common denominator of all the fractions involved is going to be pretty fast because both of them are g minus 1. Therefore, I'm going to multiply both sides by g minus 1. And then when we multiply both sides by g minus 1, those divide out. All we're left with is 8 here. These divide out. All we're left with is g plus 7. And now we solve this little equation. Subtract 7 from both sides. And we just found out that g equals 1. And we'd like to move on. But again, I said, make sure that we check to see if that solution makes one of our denominators 0. Well, when I look at this or this one, if I put 1 into either one of those denominators, it's 0. Well, I can't divide by 0 because think back if we were to check this. It would look like this. We'd put that 8, and then it'd be over. We put this 1 in here, 1 minus 1. So that's the left side of this equation. Well, that ends up being, remember, 8 over 0, and we can't divide by 0. So that doesn't make any sense. And in a case like this, if we end up with this, that tells us that there is no solution to that equation because this is referred to as an extraneous solution, which is not really a solution at all. That is your final answer to that original blue equation. Now I have one more. This one looks a little messy, but it won't be too bad. So we want to find that common denominator so that we can multiply everything, both sides, by the common denominator and then not have to worry about fractions anymore. So this first thing we're going to have to do is we're going to have to factor the r squared minus 1, which would be r minus 1 and r plus 1. And now we'll recognize this one has a factor of 1 in the denominator. So our common denominator now is going to be r minus 1 and r plus 1 because the 1 is missing both of those factors. Well, the r squared minus 1 is missing nothing that either one of the other ones have. And the r plus 1 right here is just missing the r minus 1. Therefore, like I said, r minus 1, r plus 1 is our common denominator that we're going to multiply the left side by. That's my bracket there. And then we're going to have to multiply this side by r minus 1, r plus 1 as well. All right. So on the left side, we're going to have to distribute this to the first one. Now, when we do that, I'm actually going to think of that r minus 1, r plus 1 as the r squared minus 1. So now I just have to distribute the r to r squared and the r to the minus 1. So let me just undo that so I don't have so much stuff. So r times r squared is going to put us at r cubed. R times the minus 1 would be minus r. Now I also have to distribute this to this one, but when we distribute it to there, both of these factors are going to divide out with both of those factors, and they're gone. And then all we're left with would be we have to add on just the r squared. Oops, I don't want that to be that color. I wanted it to be this color because we're distributing r squared minus the 5. Okay, and then it's going to equal, and now on this side of our equation, the r plus 1s will divide out with the r plus 1. And now we got a pretty big FOIL problem here. I'm going to take and I'm going to distribute the r first to every piece. So I'm going to go here, here, and here. And then once I'm done with that, then I'll distribute the negative 1 in. So r times r to the second would put us at r cubed, r times r squared, and r times 2 is 2r. Now I'll come back and I'm going to go with the negative 1 here, here, and here. And that's going to put us at minus r squared, minus r, and minus 2. Now I have to simplify this. And some of us would look at this and think that this is a little scary because we have an r cubed in there. But here's the thing. I'm going to subtract r cubed from the left side, and I'm going to subtract r cubed from the right side, and no more r cubes. I'm also noticing now then, since the r cubes are gone, I'm just left with r squareds. I have a quadratic. So I want to get one side equal to 0. And I'm looking at this side, noticing that r squared minus r squared, the r squareds are gone. Therefore, I want all my r squareds on the left side. So I want to get everything then to the left side and get the right side equal to 0. So I'm going to subtract r cubed like I've already said. Now I'm going to go to the r's. Well, I have this 2r here and this r here, so that would really put us at a positive 1r on the left side. So I'm going to subtract an r from both sides. And then I also have, last but not least, I'll have this minus 2 here, so I'm going to have to add that 2 to both sides so that the right side is going to equal 0. All right, so I have all this. Now, left side then. The r cubes is 0, and then I'm going to have the r squared. Negative r minus r should put us at minus 2r, and then negative 5 plus 2 should put us at minus 3. Right side, this comes out to now equal 0. Well, now I have a quadratic to solve. If we can solve it by factoring, that would definitely be the way to go. And I notice that I can factor this. This would be r minus 3 and r plus 1 equals 0. If we set both factors equal to 0, we have r minus 3 equal to 0, r plus 1 equal to 0. Solve these two little equations. So if I add 3 to both sides, we find out that r equals 3. If I subtract 1 from both sides, I find out that r equals negative 1. Now again, we have to make sure that neither one of those solutions makes the original denominator equal to 0. So if I put 3 in for r anywhere, if I put it here, well, I'm going to have a 2 and I'm going to have a 4. That's fine. If I put it into the green on the right side, it does not make the denominator 0. But that negative 1, if I put negative 1 into this second factor here, I'm going to get 0. Therefore, my denominator is 0. I can't divide by 0, and that makes this an extraneous solution. So that's not going to be one of our answers. I'm going to write extraneous solution so that we know that's why. Extraneous solution. Therefore, this one we do have one solution. We have the r equal to 3. The other one that looked like it was going to be a solution is extraneous, therefore just one solution of r equal to 3. And that's going to conclude my lesson on solving rational equations.